Hello and welcome back. Today I have something great. It's from the BG7TBL, the famous Japanese radio amateur who made a lot of designs with very nice things. I showed you already a few, but today I have the signal generator. I have them right here, and the frequency counter. Here the signal generator, it's the WB-SG1. I think it's just wideband signal generator, the first version. And this, you have two versions. You have the 8 GHz and 15 GHz. Now this is the first type. I thought for me 8 would be enough, so we're gonna play with this one. And we have the FA-2. Well, there seems to be, there was also an FA-1. I have not seen this. I have here the FA-2. And you have also two versions of this one. You have the 6 GHz and you have the 12 GHz, and maybe there is even 24. But they get really expensive. The price just doubles every time. So for me also, I thought, okay, 6 is good enough, and we're gonna play with this one. I will just put them back in their place because I have here the external reference and my 12 volt led power, because I don't want all these adapters flying around. You have seen probably in one of my other videos. So I connect them back, and then I will zoom in and we start playing. I'm trying to find an angle that you can actually read the display, but because of the backlight it doesn't seem possible, so I will use my shaky camera work to zoom in on the display, and then later when we look at all the devices I will zoom out again. Okay, we start with the generator. When we switch it on, it seems to have a default. Let me try to... Yeah, here it goes. It has a default somehow of 190 megahertz. Yeah, well, it depends on the channel, because channel 1 can do from 1 Hz up to 200 megahertz, and channel 2 can do 35 megahertz to 8 gigahertz. So I was thinking putting it on 50, and then for both channels. So let's see how we change. There is here a mode button that changes the channels. So there seems to be a sweep function. Well, I'm not using that. Let's try channel 1, probably with the arrows. Yes. Well, let's put that to 50. The PLL is locked. It's using external reference. The output is on, and the volume, can we change the volume? No, the volume is fixed. It says it's 3.3 volts peak. Well, if it's fixed, nice to know, but what can we do about it? Then we put also the channel 2. Let's also put that to 50. Now I'm making a mess. Also 50, and external ref modulation off, output on, the power is 0 dBm. So in the first channel they talk about volts peak, and in the second channel they talk about power in dBm. Well, not really consistent, but let's find out how much that is. Okay, I put it to the... I connected it to the oscilloscope, so we can see how many volts peak it is. I don't need the terminator because I'm terminating it with the Marconi, so I can see how many milliwatts we talk about, or watts, or microwatts, or whatever it will show. I'm putting it now to channel 1, 50 megahertz. It says here that the volume is 3.3 volts peak. When I'm looking at my oscilloscope, it is not 3 volts peak, it's like 2.5 volts peak. Well, that's okay. And that is about 200 milliwatts. So it puts some power. You cannot change the volume. That is a pity, because then you could have used it also to adjust your receiver, and now it's just full power. So that's not really useful for that use. I like to see what is the channel 2. So if I switch now over to channel 2, oh, I see that the channel 1 is still powered. So changing the mode button from channel is only changing the controls. It's not switching on and off the port. So that's why you had this option of output on and off. So important to know, the output keeps running even though you think you switch the channels. You're actually not switching the channels, you're switching the display. So the channel 2 is an SMA. So I have this little adapter. And remember, I put also channel 2 on 50 MHz just to have a comparison. And now they start talking about dBms instead of full peak, what I did in the other channel. So we have the same, and yeah, now we have a lot less. It's like 0.0 volts peak. It says it's 0 dBm, and the Marconi says it's like 0.8 milliwatt, so it's less than 1 milliwatt. Yeah, so there is a lot less power in the second channel. I did read, I'm not 100% sure, but I did read that the 15 gig model, this is the 8, has an amplifier there, because probably in the higher frequencies it really starts dropping. And we can also do some testing here if we see how much it will drop in the higher frequencies. But they have an amplifier there, so that one has a little bit more power than this one. So I will zoom in a bit again, and we start chasing the frequencies. So here we have it, channel 2, 50 MHz, power 0 dBm. On the oscilloscope, well, you see I'm here in 200 millivolts, so this is like almost 3, so 0.6, and the Marconi says it is around 0.8 of a milliwatt. So let's see if we start changing the frequency. I will put it in the corner. Yeah, okay, adjust. Good. So, and the buttons kind of speak for themselves. You have the enter button. Well, I didn't use that yet. You have the mode button that switches through the modes, like channel 2, channel 1, channel 2. So now we want to just start walking with the cursor up and down. So let's go to 100. Okay, 100 megahertz. We are still more or less the same on the power, only this one is from 0.7 something to 0.6 something, so the power is dropping on the higher frequencies. I can do that without the scope, maybe just to I'm putting it now directly into the Marconi without the scope in between, so I think those measurements should be separate maybe. Here again it's like 0.8, and I think in 50 I will change it back to 50. Oh, it is not right, sorry. Back to 50. We have 0.84, 0.85, and when we go to 100 it doesn't drop that much. So apparently with the oscilloscope in between, even though it's like 1 meg, it just distorts the signal enough, even though it's terminated by the Marconi. But okay, then we start going up. 200, more or less the same. 300, still I go a little bit quicker. 800, still around 80 milliwatts. Okay, so yeah, and now I'm stuck with the Marconi because I cannot go much higher, but it's still 0.83 milliwatts. So in that sense, it's really consistent over the whole range up to 1 gigahertz. I'm trying now separately the oscilloscope with the terminator, and as you can see, this is 100 megahertz, and I can only go up to 200 because then the oscilloscope stops. But you can see it is still the same. So even the volt peak and the power are both make sense. Let's see if I can go to 300. I can, but now it's dropping, but that is the oscilloscope. Okay, I'm now up to 1000, and my Marconi stopped. So the only thing I can do, but I cannot really read the power, but I can at least read the frequency from the RE2. So let's try that. It's a bit shaky, sorry. 2. Okay, the RE2 needs this. Yes, okay, 2 gigahertz. Let's go to 3. Okay, that works. 4. Probably the RE2 goes only up to 3. So I cannot test a lot higher. Yeah, I can see the level dropping. No, that's it. Okay, the RE2 goes up to 3.5. Okay, well, nice. So we can only test the higher frequencies if we start using the FA-2, the frequency analyzer type 2. Okay, here we have the FA-2. Controls as well, very easy. Channel 1 again BNC, channel 2 again SMA. It has a mode button, it has a gate button, and it has a reset button. And we are now on channel 1, and if we change mode, we can go to the statistics. We go to channel 2, and we can go to the statistics of channel 2, and we are back at channel 1. Here you can read out the power, the gate time. It's running on external ref. You can choose impedance 50 ohms, and probably you can switch that to, let me see, its fixed impedance is 50, and if I change to channel 2, it doesn't say. So let me see how I can only change the gate times. Impedance I cannot change. Okay, so that is fixed. Also it just says it's 50. Well, okay, we know that then. And the low, still I think you should be able to change that. Can I push along? How I, if it says low pass filter off and it says impedance 50, that makes you think you can change it, but I don't see how. If I push gate, it's really gate times. No, apparently you cannot. Okay, let's start putting in signal. Let's start with 100 megahertz in channel 1 from the Marconi. Okay, we're putting in 100 megahertz, and it seems that it's has a lot of variation, but it's actually below the hertz because it's behind the point. So okay, you have a power readout that says minus 15.7 dBm, and if I have a look at the Marconi, it says it's 50 millivolts, but I can change it to dBms, and then it says minus 13, so that is not too far off. And let's go to higher frequency, so let me switch to the frequency. Let's put 500 megahertz. Okay, still minus 13. And what does this one think right here? The channel 1 doesn't go that high, so we need to switch over to channel 2. Okay, the channel 2 does work, but it has less options. We don't have a power readout, and it only says the K time you can change, and the external ref displays that it is running on external, and it is jumping a bit, but again that is also in the hertzes. So what we can do is go to statistic mode, and then we can increase the gate time to make it less jumpy. Okay, now we did a few measurements, 5 to be exact. You can see that in the top, and you can see it is kind of precise because it is all behind the point hertz. And so you can see the last measurements, the average, the maximum and the minimum, and then you have the PP, and that is probably the difference between the highest and the lowest measurements. So that means the Marconi with the external reference compared to this frequency counter, frequency analyzer, also running on external, it's 0.2 of a hertz precise, which is probably enough in these high frequencies. Okay, here we have both of them open. I almost forgot to do that. And it has the famous Vectron. Well, I say famous because I also saw it in the FA-2, and it turned out to be pretty stable. They are second-hand. They probably taken out those phone towers. You can see it's all scratched and bumpy. But if they still run good, that is fine. And also I'm running them on external, so that is not a real problem for me. Yeah, I think if you have this is the signal generator. I think if you have the high frequency one, they just replace this module, but because it is always the second channel. And I see the same here in the frequency analyzer, that they just have here this little, maybe it's the prescaler, and then they just fix another prescaler in, and you could see that you could change the impedance, and well, you couldn't actually change it, it was just displaying it. And then I just wonder how they do that. So I think it is maybe also fixed, because it depends on the thing you have. So let's see if we can open a bit more. It is stuck because it's screwed on both sides and it is attached. So usually you slide it open. So probably we just need to undo this one and then the screws, and then we can take out the front, I think. Okay, let's try that. Okay, that seems exactly how that works. And well, we can take now carefully the front out. The cables are long enough, and then we are able to slide it out on the back. We'll do the same with this one. the boards look very similar. Very similar, to be honest. Yeah, these are the same, so probably the software of the display and the chip is receiving or sending a signal, and it's if I look 1, 2, 3, I really don't see what is difference. So well, it's the biggest one. Not sure you can read. Yes, it actually says here. Here it says the F count and the signal generator, so the board is indeed for both. So that was it, very quick. You have seen the possibilities of the general possibilities of the signal generator and the frequency analyzer. The statistic function is really great. You have seen that you cannot change the output levels from the signal generator. It is just switching over from port, and then you just get what it gives you. It is kind of linear up to, well, I only could have measured up to 1 GHz. So from 200 to 1 GHz, the level was linear, so that is good. With the frequency counter, it does have a power readout in dBms, but only on channel 1, and that means that is only up to 200 MHz. And when you switch to the other port, it does display the frequency. Both ports have the analytics, so you can see the averages as I show you. But it is the power readout is limited to channel 1 to 200 MHz. So that was quick, but you have seen what it can do. Thank you for watching, and I hope to see you next time.